In this video, we will be looking at waves and particle nature of light for EDEXCEL, and more importantly, we will look at specification point 59, which states that we need to understand the terms amplitude, frequency, period, speed, and wavelength, and also specification point 60, which says that we need to be able to use the wave equation, which is V equals F lambda. So here we have a series of definitions. So amplitude of a wave is basically defined as the maximum extent of an oscillation or vibration measured from the position of equilibrium. The frequency of a wave is defined as the number of wave cycles passing a given point per second. The period of the wave would be defined as the duration of one complete cycle of a wave. And the wave speed is defined as the distance traveled per unit time, which is mathematically known as speed equals distance over time. The wavelength is defined as the distance measured in the direction of wave propagation between two successive points in the wave that are characterized by the same phase oscillation. So as we can see here, the first point to the second point, that is classed as our wavelength. We have the direction of energy travel, which is going horizontally. And we also have the direction of medium oscillation. Now this is perpendicular to the direction of energy travel, as this picture itself is an example of what we would know as a transverse wave, which is why it oscillates perpendicular to the direction of energy travel. And we also have one extra term in here which is defined, or which is said here as node. And nodes are defined as points of zero displacement. And we also have things called antinodes, which will be located on top of the wave, which are basically points of maximum displacement. Moving on to specification point 60, it states that we need to be able to use the wave equation, which is V equals F lambda. We need to use this equation to be able to find the wave speed, the frequency, and more importantly, the wavelength. Now, the wave speed, it always has its units in meters per second. So if different units are given in a question, it is important to convert to the correct units before proceeding to find your unknown values. The frequency has the unit hertz, and the wavelength has the unit meters. So as we can see, here's question number 1, which says that a wave traveling at 250 meters per second has a wavelength of 2.4 meters. What is the frequency of this wave? So first of all, we use our formula V equals F lambda. It's asked for frequency, so we divide both sides of the equation by lambda, so we end up with V over lambda equals frequency. So our frequency is 250 divided by 2.4, which is given as 104.2 Hertz. The next question states that a wave has a frequency of 50 Hertz and a wavelength of 1.8 meters. Now what is the speed of the wave? For this we can just simply use V equals F lambda. So our wavelength is 1.8 and our frequency is 50, so we do 1.8 times by 50, which gives us 90 meters per second as our wave speed. The third question states that a wave with a frequency of 400 Hertz is traveling at a speed of 250 meters per second. What is the wavelength? So we use our wave equation, V equals F lambda. We want to find wavelength. Therefore, we divide both sides of the equation by frequencies, so we have velocity over frequency is equal to wavelength, and we just substitute in our numbers. So we do 250 divided by 400, which comes out as 0.625 meters for our wavelength. Now the fourth question states that a wave with speed 300 meters per minute travels with a frequency of 2 kilohertz. What is the wavelength? So before we can determine what the wavelength is, we would need to actually make the conversions into the standard units. So to convert 300 meters per minute into meters per second, we divide 300 by 60 as 60 seconds in a minute. And then to convert the frequency from kilohertz to hertz, we simply multiply 2 by 10 to the power of 3, or 2 by 1000, to get 2000 hertz. So once we have our wave speed, which is 5 meters per second, and our frequency, which is 2000 hertz, we can then go on to use V equals F lambda, rearrange the formula by dividing both sides of the equation by frequency. So we have velocity over frequency is equal to lambda. So we have 5 divided by 2000, and our answer for the wavelength is 0.0025 meters. I hope this video has been useful and helped anyone out with any questions they may have had on calculating unknowns by using the wave equation. Thank you all for watching, and goodbye.